This article, The Digital Plan of Brickwork Layout for Robotic Bricklaying Technology, was produced at the Faculty of Civil Engineering at the Czech Technical University in Prague. There is an increasing trend for using modern technologies in the construction industry. This is particularly the case in the fields of additive construction and robotic bricklaying. So we created a digital layout plan for robotic construction works, specifically for robotic bricklaying. Here we see the flowchart of the algorithm. On the left is all the input data, which is stored in a previously compiled database. On the right is all the output data. This article presents a universal methodology for creating a bricklaying plan for a variety of wall building systems. The method is based on the conversion of drawings from the BIM, Building Information Model, environment to the BREP, Boundary Representation, model through the use of the IFC, Industry Foundation Classes format. In the first step, load-bearing and non-load-bearing walls are converted from the IFC format to a BREP model. This includes windows and doors. In the next step, the object is divided into layers according to the height of the walling element. This parameter is set while drawing the model and selecting the walling element. In this step, the axes of the walls are connected. The software for modeling the BIM environment cannot connect the object axis, so these are first drawn separately. Step 4 deals with details. For these, critical points are identified in each layer of the object. Each detail is successively assigned to a specific point in the structure. There are 3 versions: corner, jamb, and T-joint. These details are prepared in advance in the compiled database of walling elements. Details in the model are displayed in the form of points with different colors according to the type of detail. In the next step, load-bearing and non-load-bearing walls are filled with standard elements inserted between mounted details. Lintels in load-bearing walls are also laid over window and door openings. These details are inserted between the points found in step 4. Step 6 is the final step of the algorithm. Here, the entire graphic model of the object with all inserted elements can be viewed. The robotic system is based on an industrial 6-axis robot consisting of several parts: an industrial robot, a load base, a universal end tool for attaching bricklaying blocks of various sizes and shapes made from standard building materials, and lastly, supporting equipment for vacuum production and signal processing. The universal end tool is equipped with a system for applying a bricklaying adhesive. It also contains several laser sensors enabling the correct and precise placement of bricklaying elements according to the coordinates from the digital layout plan. The final model can be converted to a list of elements for further calculations to optimize the use of space, or the location of a pallet with bricks, or even the robotic system itself. The goal is to reduce the movement of the robotic arm and thus the total construction time. The main benefit is optimizing the movement of the robotic arm and using the coordinates of building elements to remove them from the pallet, then place them in the required position, forming the proposed structure with absolute precision. The 2 main issues are the limitation of the system to orthogonal composition only and the cuts of bricklaying elements. The system is not capable of determining an optimal composition of the cuts for non-load-bearing walls. These elements must therefore be prepared in advance, and the composition needs to be designed manually. The functionality of the algorithm was determined during the deployment of a robotic system currently in development within the scope of the project TH04010329, Autonomous Robotic Building Systems. The main goal of the project is to develop a functional prototype of an autonomous robotic construction system to enable fast and accurate building work and reducing the number of construction workers.